Hey, it's me, Steve. What I have decided to do, since a lot of people don't understand how field work and geology works, is that I am going to take you on a real life example of what I plan on doing with the Freda Sandstone. Now, I'm going to make a separate playlist for this, but what I'm doing here, this one's just going to be a presentation. But the next few, hopefully, there will be some good field footage in it. But basically, the two pictures you saw at the beginning were along the Montreal River, which separates the UP and the Wisconsin. It's the actual very western border, and it enters into Lake Superior. And that's where those photos are from, and that's where the Freda is extensively exposed. And a lot of work has been done there. Well, for the Freda, the Freda itself has been largely neglected. But anyway, what this slide here is showing you is I'm dividing this project into 5 phases. All right. Phase 1 is background, and that was completed November 2017. It's now November 30th, 2017 as I make this video, and that's what I'm going to take you through. Phase 2 will be the coordination. I'm going to touch on that, but I haven't actually made any coordination yet. And the reason why I have late to early is because there's very many factors that can screw with the schedule, like weather, too much snow too late, or it might melt really early and raise all the creeks and stuff like that, because that's usually where the best exposures are. So that's why it just says late and early and middle on there. Phase 3 will be the actual field work, and I plan on doing that middle to late 2018. Probably between May and maybe September is when it's going to be done. Phase 4, the writing of the paper and submitting it. I probably won't submit it actually until the end of 2018, so about a year from now, maybe a couple of weeks more. And then phase 5 will ultimately be the paper modifications and publication, which will hopefully be somewhere early 2019, but it could end up being mid-2019 as well. So I plan on redefining the Freda. Well, how am I going to do that? Well, before I actually go out and do any of that, I had to get background. All right, this slide here, this is from my last paper, which I redefined the Jacobsville here. And this is what we call a time correlation chart, basically just showing you how the units have been defined throughout the years. The one on the far right shows you where the Freda formation is. I have long suspected the Freda can be divided into units. I just didn't do it here. And others have tried, which I'm going to get into in a minute. But this paper is from, there's the paper title, and that's the journal you can find it in. All right, now here is just the paper titles on the left, and on the right is just another one of roughly correlative chart for the deposits between the Mid-Continental Rift and the overlying clastic deposits. And this has actual dates on it, though, so I just wanted to show you that, and shows a timeline at the top. Now, these are the major publications I'm working from, all right? Basically these 6. Now, as you can see, the dates on them, like the Sandstones of the Wisconsin Coastal Lake Superior, that was 1912. And then I had to drive the one in the upper right here, sequence of northern Wisconsin and adjacent Michigan, stratigraphic sequence. That was a dissertation or thesis, PhD, done in 1968. I actually had to drive to the University of Wisconsin and scan this thing in order to obtain it. It's not available anywhere free online that I could locate. So that was, hopefully I won't have to do that again. There may be some other publications, or there will be some other publications I'm going to work from, but these are the main papers or lengthy publications and state surveys that I will be working from. All right. And we'll also be using geologic maps. And the 5 main ones, these are the titles I've took screenshots of to show you those. In this next slide here, this is just clips from the maps. And the reason why I love these maps is because they show the outcrops, the outcrop areas. And that's what's circled here in red. Obviously, I didn't circle every little outcrop, but basically these darker areas on the four on top, that is where the outcrops are exposed. And this typical brown color in the upper left one, it's kind of lighter brown, is the Freda. In the lower right one, the outcrops were designated by red hatched lines, and that one is really old. I believe it's from, is it 1912 or something like that? I forgot exactly when it's from. That one coincides with Bulletin 25, I believe, which is actually 1912. Yeah, I believe it's 1912. All right. So, Wisconsin also has online an interactive map where you can go and pick outcrop locations. All right, and a basic description of those locations. And here's the 5 I plan on using. Actually, I think there's a 6th that I may or may not use, but the 5 I know I'm going to use are right here, and that will help guide me to show me exactly where to go to look for what I need to know. And most places, most states don't do that, but Wisconsin does. Now, that 1968 dissertation was done by Height, and I went through that entire thing and pulled out everything I could think of that I would need to develop a conceptual research model for the Freda. Because before I even go out there, I want to have something in my head, some sort of model. All right. And the purpose of going out in the field is to confirm or refute that model or make changes as needed, because the ultimate goal is to actually represent what's in the ground, not just my concept. All right. But I still need to develop a concept, all right, to guide me. And what you see here in this slide, like it says, all locations, red are outcrops, yellow are cores, and blue are well logs. These are all the things I plan on studying. The well logs are in blue, and they're not really very good. I may just use them for depth of rock. There's 51 of those red spots. Almost all of them are Freda. All right. The yellows are cores that I have requested from the state of Michigan to get logs on, so I can actually narrow that down, because these cores can be pretty long, and like the St. Amour core, which I've already looked at, I'm going to have to look at again. But this is my area of study. All right. And this is a map I generated based on Height's 1968 and Tyler's 1940. Well, some people say it was 1940, some people say 1941 it was published, and then Thwaite's 1912 publication. And I have developed a conceptual model of the Freda, what I think based on those publications, how it relates to things in the field, and this map shows you that. And if we zoom in, just to highlight some of those things, there was a legend there in the far left one and the top middle one, and on the upper right and lower diagram, just zoom ins. This is the model I'm developing, and I'm actually already running into problems with this model, which is good because that means that there's still more to learn, and I am really excited to get out there and do this, because this will likely be the last of the Mid-Continental Rift sedimentary units that I actually describe. And I will also be using cores. This is a core. I went to the Michigan core list and pulled these from it. There's actually several pages, but the top is just ones I selected. I put my numbers on the far left, and as you can see on the bottom, I zoomed in on one. There's 24 potential ones. I need to lower that down to like 5 or 6. And unfortunately, the core library is presently in Marquette in the UP, but they plan on moving it. So my time scale to get this done, that could jack everything up if they don't move it within the next year or two. So this paper could end up being a 2020 thing, the year. But what does a core look like? This was the St. Amour core that I did when I did the Jacobsville, and that's basically how cores appear in core boxes. I just wanted to show you that so you could get a sense of it. And that coin on the right is a US dollar coin for scale. So after that, what I need to do is I need to coordinate this. All right. So what do I need to do? Well, roadsides and public creeks are fair game. I can go down there. I can take samples, pictures. I don't have to worry about it. State parks. There are a few state parks in here. I think off the top of my head there's 3. I need to get permission to take samples. I've done that before. They're very Wisconsin and the UP are generally really good at that. They don't give me any qualms about it. There are no federal lands there, so I don't have to actually fill out a form this time. Where I may run into a problem is that last one, private land, and there are at least 5 of these sites that I know are on private land, and most people are pretty liberal when they about letting you go on there as long as they know what you're doing. I don't. However, it could be a problem, and that's why I have 51 sites to visit, because it will likely be narrowed down to 3 dozen or 30. So that's what I need to do. I need to coordinate with private landowners if I can locate them, and if I can't, then I just won't go there. I'll have to rely on some other method to find out what I need, and that happens a lot. But I want to plug here Lake Superior Geology. .org, which is the Institute of Lakes on Lake Superior Geology's website. I've been going to these conferences since about 2011, I think, and the upper left is the main website. This list here in the middle, the link down in the lower right is the one that'll take you directly to that, and they have been around since 1955. They're having these conferences every year, and I will be using a lot of their guidebooks as sources as well. And I have also contributed to this for several years and stuff like that. And they're really good resources. And if you're interested in the geology of Lake Superior, I suggest you go here and take a look at their stuff. But that's basically the plan in a nutshell. And I will, when I'm out there taking measurements, taking photos, I will show you the actual process of how that is done. So I just wanted to show you how phase 1 was done and beginning of phase 2, and that is it, and I hope you learned something.